All right, let's finish the second part of activity 6. So just a couple of reminders of things that we looked at last class is we started looking off, or what activity 6 was, is you're pretty much trying to prove what shape, or classify a shape, based on some of the properties that we've already looked at. So let me just give you a couple of reminders. With parallelograms, one of the first things that we saw is you can look at the opposite sides, and if they're parallel to each other, then that makes it a parallelogram. The way that we figured out whether some sides were parallel or not is we found their slope, and if they have the same slope, that means that they are parallel. Okay. The next thing that we looked at, and the next way that we looked at is looking at opposite sides. If the opposite sides were congruent, then that made it a parallelogram as well. So we found the opposite sides by using the distance formula. So we found the length of each side and then compared it. If they had the same length, that means those sides were congruent, and that's what made it a parallelogram. And almost last but not least, with this one right here, we have if one pair of opposite sides of a quadrilateral are congruent. So to do that, we are going to be using that distance formula again. So that's what we did. And parallel, so we use your slope formula right here. Really, this one right here is just a mixture of these two. Instead of doing all four sides, you're only picking two of them. So if I was doing this problem, I would just pick this one, and then I would find the distance of this one and this one as well. Okay, so like I said, this is just a combination of these two right here. All right, and last but not least, we have this one. If you look at the diagonals and they bisect each other, remember bisecting each other means cutting in half. So to find that halfway point, we are going to be using the midpoint formula. So you find the midpoint of each diagonal, and if they match up, that means that they intersect at that point, which means they bisect each other. Okay. Then we moved on to rectangles. So the way that we were looking at rectangles, one of the first things that we started with looking at is that rectangles are opposite reciprocals, or they have 4 right angles, which means that their slopes of these two sides are opposite reciprocals. That means they're perpendicular. Okay. The next thing that we saw about diagonals is that rectangles, is that their diagonals are congruent. So those were the two methods that we were looking for. I told you that you could start with whatever. You have to start by proving something is parallel, or a parallelogram, which is what we did here. And I mentioned to you last class that if you do this method right here, you can go ahead and see if it's a rectangle just by looking at its slopes. Remember what I just talked about right here. If it's a right angle, then the slopes are opposite reciprocals. Opposite reciprocals means that one's going to be positive, one's going to be negative, and reciprocal means to flip. Okay, so if you look at these, one's positive, one's negative, and one's positive, and this one right here is negative, and then you can flip them. If you flip 1 over 3, it becomes 3 over 1, which is 3. Okay, if you were looking at this first one right here, and I asked you, hey, are these is this a rectangle? I mean, looking at it, some of you will be like, no, it's not, because it doesn't look like a rectangle. But you can look at the slopes and identify that. So if I was looking at, what side is this? HC. So we were looking at this side right here, and this side right here is AC or CA, which is this right here. And then you just have to compare them. Is one of them positive, one of them negative? No, they're both positive. Is one of them the flip version of the other? No, it's not. So this one is not a rectangle. This one's just a parallelogram. Okay. All right. The next way that we saw for rectangles is we compared their diagonals. So remember, if the diagonals are congruent, so we do that by using the distance formula, looking at the diagonals. If the diagonals measure the same thing, they are the same length, that means that they are also a rectangle. Or that's another way that you can prove something is a rectangle. Now, where we left off last class was just looking at a couple of characteristics for a rhombus. One of the things that we have for a rhombus, and I'm going to teach you how to do this one right now, or actually towards the end, is that all 4 sides of a rhombus are congruent. So all 4 sides are the same. So really with this right here, I'm not going to do an example of it, but I do just want to show you that we've already technically done a way to figure out whether a shape is a rhombus. So let's go back right here. Oops, this one. So if you have these right here, and I would ask you, hey, I know this one's a parallelogram because the opposite sides measured the same, but is it a rhombus? The way that you would test it is you would just look at all the four sides. If all four sides give you the same number, then that would be a rhombus, okay? So looking at this one is not a rhombus because all four lengths are not the same. So when you're looking at the parallelogram, if I was picking which of the methods I would like to do for any of my questions, I would either do this method right here because this method helps you get whether or not it's a rectangle, or this method right here because this one helps you realize whether or not this is a rhombus. So these two methods right here let you essentially just do one set of work and help you classify it either as a parallelogram or a rectangle. Same thing, this is just one set of work and it helps you figure out whether it's a parallelogram, but also helps you see if it's a rhombus or not. Okay, and I'll show you an example of that in that last page. It has two good examples of how your questions are going to look like for your tests and your quizzes and stuff. Okay. All right, the next thing that we saw about a rhombus was if the diagonals are perpendicular. Now, perpendicular, let's go ahead and write some notes for that. What perpendicular means is that we're going to be using slope. So m equals 2, and I'm just going to rewrite it because we have our slope formula all the way in the first page or something like that. So this is our slope formula, and we want to get opposite. And opposite, remember, means one of them's positive, one of them's minus. Reciprocals. Reciprocals means to flip. So I want the answers to be flipped. Okay. So when we're doing our work in a second, I want to look at the diagonals, get their slopes, and see if they are opposite reciprocals. And if they are, that's what makes it a rhombus. Okay. So let's go ahead and get started with that. So like I said, perpendicular is what we're going to be using, and we want our slopes to be opposite reciprocals. Okay. All right, so the first thing that I always do is go ahead and check whether this is a parallelogram or not. You're going to be doing that by doing my preferred method. And again, this is really up to you to choose whatever. But I always start with this method, which is finding the slope of each side. So we're going to find the slope for this quadrilateral. So our quadrilateral is bird. So let's just go ahead and draw ourselves a picture of that. Like I said, there will not be any pictures given to you, and so I always like to draw some. That way I know I'm putting my things in the correct order. Okay. Now we're going to start comparing sides. We're going to compare BI and DR. So I want you to go ahead and find the slope of BI. All right. So if you're trying to find this slope right here, B. And remember, the x's go on the bottom, the y's go on the top. B is -2, so that -2 goes on the bottom. And then -3 goes at the top. I is 1, 1, so that 1 goes at the bottom, the 1 goes at the top. Go ahead and solve for that. -3 minus 4 is -4. -2 minus 1 is -3. Go ahead and simplify that. Negative divided by negative is positive, so +4/3 would be our answer for this one. All right, let's go ahead and find the slope for RD. So R is the one we're starting with. Remember, the x's go on the bottom, so 6 goes at the bottom. And I guess I started with D, sorry. So 3 goes at, so yeah, I started with D. D is 3, -3, so D is 3, -3 would go at the top. And then R is 6, 1, so 6 goes at the bottom, 1 goes at the top. Go ahead and solve for that. And you're going to see, like, I know I flipped them. You will get the exact same answer whether you flip them or not, okay? -3 minus 1 is -4. 3 minus 6 is -3. So -4 divided by -3, negative over negative is positive, so 4/3. So if I compare those, they are the same, which means those opposite sides are parallel. Okay, go ahead and find the slope for these next two sides. We're going to find the slope for IR next. All right, for IR, we're going to start with I. I is 1, 1, so the 1's going to go at the top and the bottom. R is 6, 1, so 6 at the bottom, 1 at the top. Go ahead and simplify that. 1 minus 1 is 0. 1 minus 6 is -5. which equals to 0. We're going to do the same thing for DB. So let's start with D. D is 3, negative 3. So the 3 goes at the bottom. Negative 3 goes at the top. B is negative 2, negative 3. So that X goes at the bottom. So negative 2 right here at the bottom. Negative 3 at the top. And that would be 0. And then positive... That should have been a positive 5, actually, not a negative 5. Because 3 minus 2 would have been 5. Yes, that shouldn't have been positive 5. So 0 over 5 would have been 0. Okay, the point is that they are both the answer of 0. So because they're both the same, that means that they are parallel, which makes it perpendicular, or a parallelogram, sorry. Okay, so if I was looking at this question, not only can you answer if this is a parallelogram or not, you should also be able to tell me if this is a rectangle. Okay, so I am able to tell you that this one is a parallelogram, which is awesome. That's what we're kind of figuring, but I can also tell you whether or not this is a rectangle. Remember, if this is a rectangle, pick two sides that are next to each other and their slopes should be opposite reciprocals. So if I look at, this is side BD, which is right here, and this bottom side is DR, or RD, which is right here. If I compare them, 4 over 3 and 0. If you flip 4 over 3, it's 3 over 4. That's not what's happening here. So this one is not a rectangle. And I can just tell because of those slopes, okay? So the way that your questions are going to be given to you essentially is it's just going to be this. Given da-da-da-da-da-da, and it's going to say classify the quadrilateral. And so it's going to be your job to figure out, is this a parallelogram? Is it a rhombus? Is it a rectangle? So it's not going to be kind of like how these are set up for you and all the sides are labeled and I tell you what to start with. You're going to have to kind of come up with that on your own. Okay. All right. Next way for us to figure out, right here, we just looked at it and realized that it is a parallelogram. We're going to go ahead and do the work to see if it's a rhombus. So for this one, we're just going to go ahead and draw a new picture real quick. We're using this theorem 9 right here, which is if the diagonals are perpendicular, then it's a rhombus. So we're going to be working with the diagonals. So BR and ID, and we're going to be looking at their slopes, okay? Go ahead and find the slope of BR. All right, so for BR, B is negative 2, negative 3. So we're going to put negative 2 at the bottom, negative 3 at the top. R is 6, 1, so 6 goes at the bottom, 1 goes at the top. When you simplify that, that's negative 4. Negative 2 minus 6 is negative 8. When I simplify that, we have negative over negative, which is positive. And 4 over 8, I can simplify that. I can divide this by 4 and divide this by 4. 4 divided by 4 is 1. 8 divided by 4 is 2, so 1 over 2. And now let's find the slope of ID. Go ahead and do that real quick. All right, the slope of ID, so I is going to be 1, 1. So we're going to put 1 here, 1 here. D is 3, negative 3, so the 3 goes at the bottom. The negative 3 goes at the top. So 1 minus 3, that turns into a plus. So 1 plus 3 is 4. This should be 4, not negative 4. What am I doing? Okay, and then this over here at the bottom is 1 minus 3, which is negative 2. So 4 divided by negative 2, that's just negative. And then we can divide those by 2. So 4 divided by 2 is 2. And then negative 2 divided by 2 is just 1. So 2 over 1, it just becomes 2. Okay. So now if I look at these right here, we're going to be looking at whether or not it's perpendicular. Now remember, what makes it perpendicular? If the slopes are opposite reciprocals. So opposite means one's positive and one's negative. So let's check that. One's positive, one's negative. Check. All right. The next thing is they have to be reciprocals. Reciprocals means that they are the flipped versions of each other. So if I flip 1 over 2, it's going to give me 2 over 1. And what is 2 over 1? 2. Okay, so they are reciprocals. So because they are opposite reciprocals, that means yes, this is perpendicular. So that means that this is a rhombus. Okay. So when you would classify this, I would no longer say it is a parallelogram, because this right here is enough of a description for it. So the best way that I can kind of remind you of that is I'm going to bring up my little dog comparison here. I'm going to try to put it somewhere where you can kind of see it. Okay. I don't like, if I see a dog or Labrador, right? I just say, oh yeah, that's a Labrador. Yeah. You don't have to go back and say, oh yeah, it's a Labrador. And by the way, it's also a dog. No, because it's a Labrador, then I know it's a dog. I don't really have to go into this description. So same thing here. If it's one of these more detailed or more specific classifications, you no longer have to describe it as a parallelogram. Saying it as a rhombus or rectangle or square is enough, because I know a rhombus is a parallelogram. I know a rectangle is a parallelogram. I know a square is a parallelogram. Okay. So same thing. If it's a Labrador, you don't have to be like, oh yeah, it's a Labrador, and by the way, that's also a dog. No, I already know that. So you don't have to be specific, or you don't have to go back and tell me it's a dog. Just say it's a Labrador. Okay. This is implied. So here I would just say it's a rhombus. Okay. All right. And last but not least, the last theorem for a rhombus is if a diagonal bisects a pair of opposite angles, then the parallelogram is a rhombus. You're not really going to be using this one. Okay. All right. Last shape, a square. Now, a square is a combination of everything. So what I mean by that, and this right here is a very simplified way of finding these answers, and I'll tell you why. Essentially, if I was giving you a question like this, like on a test or whatever, I would just give you the sides. It's going to be up to you what method you decide to use. So if you decided to use this method right here, like I said, this is extra work. You didn't have to do this, honestly. You could have stopped right here. So what I mean by that is you could have gone in and told me whether or not it was a parallelogram by looking at the opposite sides and seeing that they have the same slope. Because if they have the same slope, they're parallel. Wonderful. It's a parallelogram. The next thing you could have done was, okay, well, now let me compare again, just like we talked about last class, compare the consecutive sides and see if they're opposite reciprocals. And if they are, oh, well, this one is a rectangle as well. So this shape right here, I've already classified it as a parallelogram, and I've classified it as a rectangle. The last thing that you need to do is check if it's a rhombus. It's up to you which way you'd want to see if it's a rhombus. Though different ways for you to use that are, you could do this right here that we did here to figure out if it's a rhombus by taking the slopes of the diagonals. You could also look at all four sides and take the lengths of the four sides and see if the four sides are the same, and that would tell you if it's a rhombus. So if I do this work right here and I already see it's a parallelogram, I see it's a rectangle, and it's a rhombus, let's just pretend. I don't think these are, but if it was a rhombus, guess what? If it falls under all three of them, then it is a square, okay? I'm going to bring up my dog example again. If it's a dog, and it's a rectangle, a poodle, and it's a Labrador, then that means that it is a Labradoodle, okay? So if your shape works for all of these things that we've done, that means that it's going to be a square, okay? So let me just go ahead and show you one way of doing that for a square. So really for a square, we can just go ahead and use the criteria. And these criteria come from rectangles and from rhombi, just FYI. So essentially what you would do first is you would go in and you would check whether it's a parallelogram first, okay? Once you checked if it's a parallelogram, then you can just do this step right here. And these two are actually from the rectangles and the rhombi that we already did. We just put them in one page, okay? So first things first is, let's go ahead and label that. It's DAVE. We're working with the diagonals here for this question. This right here, where diagonals are congruent, that's from a rectangle, okay? This right here, where we're checking the slopes of the diagonals to check if they're perpendicular, that's from a rhombus. So this work right here shouldn't be new. That's this. Same thing with, this work right here, that should not be new. That came from this, okay? So this should not, or look anything new. Really what you're doing is we just combine them because again, a square is a rectangle and a rhombus, okay? So let's go ahead and start by finding the distance of those diagonals, or the length of those diagonals, I'm sorry. So go ahead and find the length of this DV and AE. All right, for the length of DV, D is negative 1, 1. Remember, for the distance formula, X's go here, Y's go here, so negative 1, 1. And then V is 6, 6, so 6 goes here and 6 goes there. For AE, A is 0, 7, so 0 goes there, 7 goes there. E is 5, 0, so 5 goes there, 0 goes there. When I put that in my calculator, I get 8.60 for each one. Okay, so far my diagonals are congruent, which means this one is a rectangle. So all of this work right here, it just proved that it was a rectangle. Okay, so let's go ahead and write that down. So quadrilateral Dave is a square because the diagonals are congruent. So all that work that I just did just proved that it was a rectangle. Okay. Next thing, we're going to look and see if it's a rhombus. So to prove it's a rhombus, we're going to take the slopes of those diagonals. So go ahead and get the slopes of those diagonals, please. All right, to get the slopes, we're going to start with DV. So D is negative 1, 1. Remember, the X's go at the bottom, the Y's at the top. So negative 1, 1. V is 6, 6. So 1 minus 6 is negative 5. Negative 1 minus 6 is negative 7. All right, go ahead and find the slope of AE, please. All right, to get the slope of AE, A is 0, 7, so 0 goes here. And I'm sorry, I didn't simplify that one. That one would be 5 over 7, but A would be 0, 7 at the top. E is 5, 0, so 5 at the bottom, 0 at the top. Go ahead and simplify that. 7 minus 0 is 7. 0 minus 5 is negative 5. So that would equal to negative 7 over 5. All right? And then compare them to see if they are perpendicular. When I look at these right here, first we need to see, are they opposite? So is one of them positive and one of them is negative? Yes. So that checks out. Okay? Is it reciprocal? Is it flipped? 5 over 7. Flipped is 7 over 5. Yes. Okay, so because it's both of them, that means that it's opposite reciprocal, which means the diagonals are perpendicular. So the diagonals are congruent and the diagonals are perpendicular because slopes are opposite reciprocals. Okay, so all of this work that we did right here was for the square, and this shouldn't have been new. This came from the rectangle, this came from the rhombus. Okay, we just put it in one section to prove that it's a square. All right, let's look at some of these, and I'm hoping maybe you started memorizing them. And if you don't have them memorized, that's totally fine. I don't expect you to. These are a lot of rules, but that you have made a space in your composition notebook and write them down the day of your review, and that way you can have them for your test, okay? So I'm just going to go over this Venn diagram again. Everything that we've been talking about has been over polygons. So polygons, remember, are shapes with straight sides. All we're doing is just getting more and more specific, okay? So if I was comparing this to animals, I would just say, animals. And then I'm getting more and more specific, okay? I started off with polygons, and then I said, well, what type of polygons? Quadrilateral specifically. So same thing. Animals, let's get more specific. Mammals, okay? When we're talking about quadrilaterals, there's a couple of types that we've talked about. We talked about a kite. A kite, really, we didn't say anything super specific about it. We just gave you, or they didn't have any further classification inside of kites. So kites are really just this bubble that's by itself. Okay. Then we talked about parallelograms, which does have a couple of subsets inside of it. And then we also talked about trapezoids. So kites was this one right here that didn't really have a lot of things in it. Trapezoids, the only new thing that we looked at trapezoids were isosceles trapezoids. So it's this one right here with just one bubble in it. And that one bubble is isosceles trapezoids. And so this big bubble right here is going to be your parallelograms. And then we have these bubbles right here. F and G are going to be your rhombus and your rectangle. And where they intersect, or a shape that is both of them, is going to be your square. So let's go ahead and label that really quick. Okay. All right, this right here has pretty much a lot of your properties. I will say it's lacking with your trapezoids and kites, so I would not just be like, oh, this has all of my rules and I'm just going to copy this. It does not have all of them, so go back in your notes and get all of those. But 4 sides, all of these have 4 sides. Opposite sides are parallel. For quadrilateral, not all opposite sides. Kites, not any of the opposite sides. And trapezoids, not all of them are parallel, so that's just for parallelograms. Opposite sides are congruent, that's all parallelograms again. Opposite angles are congruent, all parallelograms. Diagonals bisect each other, all parallelograms. Consecutive angles are supplementary, all parallelograms as well. Diagonals are perpendicular. Now that is for kites, and that is for a rhombus. And if it's for a rhombus, well, what other type of rhombus is there? Remember, look at your Venn diagram. Squares are also rhombi, so we would put our check mark there as well. For right angles, you're going to see a rectangle has 4 right angles. And because a rectangle does, what goes under a rectangle? A square, okay? 4 congruent sides, same thing. A rhombus has 4 congruent sides, so a square has 4 congruent sides as well. And exactly 1 pair of opposite sides are parallel. That is a trapezoid, okay? So let's go ahead and look at these examples right here. And this is a little bit closer as to what you're going to get, okay? Use the coordinates for parallelograms to show that the quadrilateral, use the conditions for parallelograms to show the quadrilateral W, X, Y, Z with vertices W, X, Y, and Z, okay? So we're going to prove that it's a parallelogram by using our different methods, okay? So I'm not really going to stop you here to kind of explain them. I'm hoping that you're going to take the time to do this by yourself. So I would just pause right here and just make sure to try to work these by yourself and that you can do them. Because this is really your test and so forth is going to look like. And not really even because I labeled things for you. I'm not going to label anything for you on your tests, okay? So go ahead and pause and try this question on your own, or at least the first one. All right, for a quadrilateral, oops, give me 1 second. All right, for a quadrilateral, we have W, X, Y, and Z. So I always start by drawing out my picture. Just follow around the shape. So W, X, Y, and Z, and that way you label everything correctly. The first way that I can see whether or not something is a parallelogram is I can start by comparing its opposite sides and check if they're parallel. Okay, so that's what I'm going to do here. So to do that, I'm going to find the slope of that side right here. And this is what I'm saying, like I didn't give you all the little spots, and I always like write out the formula with just the numbers missing so I can make sure that I put it in the right spots. So this is WX. So W is -3, 3, so it looks like this. X is 2, 5, looks like this. And that's going to give me -2, -5. All right, next one is ZY or YZ. And this is 2 over 5, sorry. Okay, to find the slope of YZ, so we're looking at Y and Z. So let's go ahead and do that. Y is 1, 2, so it looks like that. Z is -4, 0, and that's going to give me 2 over 5. So looking at the slopes, they are both 2 over 5, which is good for me so far. They are parallel, so one side is parallel, okay? All right, let's go ahead and look at the next 2 sides. So we have XY and WZ. So let's look at XY first. X is going to be 2, 5. So 2 goes at the bottom, 5 goes at the top. Y is 1, 2. So 1, 2 like this. Put that in your calculator. That would be 3 over 1, which is just 3. Let's do the same thing for ZW. So ZW is going to be, Z is -4, 0, so -4 at the bottom, 0 at the top. W is -3, 3, so -3 at the bottom, 3 at the top. Go ahead and put that in your calculator or just do it in your head. That would be -3 over -1, which is negative over negative is positive, so 3 divided by 1, which is 3. So they both have an answer of 3, which means that they all have the same slope. So same slope. So opposite sides are parallel. I'm hoping this is kind of what you got for this question. Like I said, pause, try the next one. I'm going to be moving on to this next one right here. All right. And actually, before I go on to that one, just with right here, I can tell you that this one is a parallelogram. But what if I asked you, is this one a rectangle? Yes or no? So if I'm trying to see if this one's a rectangle, you were just going to look at the two sides that are consecutive. So we're going to be looking at WX, so that 2 over 5. And Z, or not WX, I'm sorry, it's WZ. So WZ is this, or ZW right here, this 3. And this bottom side right here is YZ. So we're looking at this one. And then you compare them. Are they opposite reciprocals? Not. So they're not. Okay. Not one is positive, one is negative. That's not, so they're not opposite. And they're not reciprocal, so they're not flipped. So this one's not perpendicular, which means this is not a rectangle. Okay. So if I was doing the work for this one, I could do this work right here. And that would be enough for you to tell me, hey, this one's not a rectangle. So far, this shape is just a parallelogram. Okay. All right, the next way that you're going to do it, and this is where you're going to go ahead and find the sides. Whoa. Find the sides. Let me go ahead and go back to where I was. There we go. So looking at the distance for those two sides right there, we're going to find that length. So WX would be -3, 3. Let me get to that point. There you go, -3, 3. X is 2, 5, so 2, 5 goes right here. Y is 1, 2, and then Z is -4, 0. So before I do that, so 1, 2, -4, 0. We're going to find the length of both of those. When you put both of those in the calculator, you should have gotten 5.39. 5.39. Okay. Let's go ahead and find the other two sides. So this one right here, WZ and XY. So finding those lengths right there, we started off with Z, I guess. So Z is -4, 0. There we go. -4, 0. And then W is -3, 3. So like that. And then XY, X is 2, 5. So 2 goes there, 5 goes there. The Y is 1, 2. So 1 goes there, 2 goes there. You're going to pop that in your calculator, and that's 3.16. Okay. All right, so I got the lengths of those, and what this proved right here is that the opposite sides, so these pink ones and these yellow ones, opposite sides are congruent. And if the opposite sides are congruent, that means that this one is a parallelogram. The other thing that I could get from here is to see if this is a rhombus or not. So you would just compare all of these sides, okay? And you would just say, okay, well, are all 4 of them the same? They are not all the same. So because all 4 sides are not congruent, that means this is not a rhombus, okay? So this is what I'm talking about, where like when I'm asking you a question to classify a shape, you don't have to do more work than you have to. Essentially, like we were going to do this work either way for a parallelogram, okay? So with this work, I could figure out it's not a rectangle, okay? So if I were you, I would do this. And that would tell me it's not a rectangle. And then to find out whether it's a rhombus, you can do this. Or why do so much work? You could also just do this little work right here of getting the slopes of the diagonals. Okay. Ooh, let me get back to where I was at. Okay. All right. Next one. This one right here. I am not going to do that work all over again, but if you wanted to, you can do a combination of these two, and really it's just doing half of each work. So you would just have to do this work right here, do that same work right here. And then if one side had parallel sides and one side had congruent sides, that was enough for you to tell me that they were parallelograms as well. I'm just not going to write it all over again, okay? All right. This one right here, prove that it is a parallelogram by showing its diagonals bisect each other. So we're going to be working with the diagonals, finding their midpoint. And if they have the same midpoint, then it is bisecting each other. So for this one, W is -3, 3. This is probably my least favorite way because you don't get anything else from it. Really, we're just finding out that they bisect each other, but this doesn't help me figure out whether it's a rectangle or rhombus. So if you want to do it this way, you can, but this is probably my least favorite method. Y is 1, 2, so we have that. When we find that that midpoint, it's negative 1, 2.5. All right, let's do the same thing for ZX. Here is that midpoint, and that would give me the same answer, okay? So midpoints were the same, so that means that they bisected each other, okay? So these are the 4 different methods that you can use to figure out whether a shape is a parallelogram or not. Like I mentioned, based on which one you choose, you can also see if it's a rhombus or a rectangle. I would not do these 2 at the bottom. I would do these 2 at the top, one of them. You don't have to do both. If you do both, it will tell you if it's a rectangle or rhombus. So if you want to stick to just doing these 2 methods, but I know it's a lot of work, and so some of you are going to be like, no, I don't want to do all that, okay? But pick one of these 2 right here, because what that means is as you're getting through your classifications, not only will this work tell you if it's a parallelogram, it will also let you know if it's a rectangle or not. Not only will this tell you if it's a parallelogram, but it'll tell you if it's a rhombus or not. Now, if I asked you, is this shape right here a square? You should tell me, no, it's not a square. Because it is not a rectangle and it's not a rhombus, then it can't be a square, okay? Again, bringing up my dog example, and I keep bringing that up. If it's not a Labrador and it's not a poodle, then it can't be a Labradoodle, okay? All right, let's do the work for those rectangles and rhombus in that second example, okay? These are all the methods that you can use to find whether or not it's a rectangle and a rhombus. So let me just go ahead and label that. And again, I'm going to just tell you to pause, and I'm hoping that you kind of work on these by yourself and you're able to do them by yourself, okay? So let's go ahead and look at this one. So pause and see if you can do that first one. All right, so finding the slopes of each side, this again is very similar to what we did with parallel, not very similar, it's exactly what we did with parallelograms, so I'm hoping you know how to do it. Finding those slopes right here of MA and HT, go ahead and check your work with me. M is -4, -2, so the -4 goes at the bottom, -2 goes at the top. A is -3, 3, -3, 3 like that. Simplify it, that's -5, -1, which is just 5. For HT, H is 1, -3, 1 goes at the bottom, -3 at the top. T is 2, 2, so 2 goes at the bottom, 2 goes at the top. That's going to be -5 over -1, which is just 5. So far, those 2 sides are parallel. All right, let's do the work for the rest of them. So AT and MH. So AT, we have -3, 3, so -3 at the bottom, 3 at the top. T is 2, 2, so 2 at the bottom, 2 at the top. Go ahead and just simplify that. That gives me 1 over -5. All right, let's do the same thing for MH. So MH is M at the, or M is -4, -2, sorry. So -4 at the bottom, -2 at the top. H is 1, 3, so 1, -3 like this. Go ahead and simplify that, and that's going to give us 1 over -5 or -1 over 5, okay? Now, if I was just asking you, is this a parallelogram, yes or no, you'd be like, yes, because opposite sides have the same answers. Now, if I was asking you, is this a rectangle, you should look at consecutive sides. So this so far is a parallelogram. Now, if you're trying to figure out whether this is a rectangle or not, look at the consecutive sides. So we're going to look at MH and HT. So MH is this one, HT is this one, and you're just going to see, are they opposite reciprocals? So are they perpendicular or not? So is it one of them positive and one of them is negative? Yes. Is it flipped? Well, if you flipped 1 over 5, that's 5 over 1. So yes. Okay. So they're perpendicular because slopes are opposite reciprocals. So this one is perpendicular. So this is a rectangle. Okay. So this is one way of finding out whether it's a rectangle or not. Okay. This is all the work that I would do. Okay. I'm going to do this extra work just so you can have it. So let's just say you decided not to start with this. This is another way that you can find out whether it's a rectangle or not. Or you can do this by, or you can maybe pick this one because you think it's easier, okay? So find the length of the diagonal. So I can also go ahead and find the lengths of these diagonals. So MT is that first diagonal. And AH is that second diagonal. Let's go ahead and find the length of those. So M is -4, -2. So -4, -2 like this. T is 2, 2, so 2, 2 goes like that. A is -3, 3 like that. H is 1, -3 like that. Pop those in your calculator and that gives us 7.21, 7.21, okay? All this tells me is that the diagonals, are congruent, which is one of the rules for a rectangle. So that's enough for you to tell me it's a rectangle as well, okay? All right. So if I was figuring out whether or not this one is a rhombus, so far we know it's a parallelogram because of this work. We know it's a rectangle because of this work and this work. Now let's figure out whether this one is a rhombus. So to figure out if it's a rhombus, show that all four sides are congruent. So we're going to work with all four sides and we're going to check, are they congruent or not? So let's start with these two right here. So MA and HT. And we're going to find their length. So M is -4, -2, so -4, -2. A is -3, 3, so -3 goes here, 3 goes there. H is 1, -3 like that. And then T is 2, 2, so it goes like that. Pop those in your calculator. We got an answer 5.10. So far we're on the right path to seeing that this is a parallelogram because these opposite sides are congruent. Okay, so let's go and look at those other two sides. So MH and AT. All right, M is -4, -2. H is 1, -3. A is -3, 3. And then T is 2, 2, like that. When I pop that in my calculator, I get 5, 10. So what that told me was that MA and HT are congruent, and MH and AT are congruent. So far all this work tells me it's a parallelogram. Not only that though, all four sides are congruent. So this is also a rhombus, okay? So this work was to tell me it's a rhombus as well. That's why I said that either pick this one or this one as the first two methods that you do when you're working on your things, okay? Because this one will tell you it's a parallelogram and tell you if it's a rectangle, and this will tell you if it's a parallelogram and a rhombus as well, okay? The other way to figure out if it's a rhombus or not is by using its diagonal. So MT is the one we're going to start with first. Go ahead and look at its slope, and we're going to look at the slope of the other diagonal. So M is -4, -2, -4 at the bottom, -2 at the top. T is 2, 2 like this. Go ahead and simplify that. That's -4 over -6. We're going to divide by 2. So negative over negative is positive, first of all. And then 4 divided by 2 is 2. 6 divided by 2 is 3, so 2 over 3. Let's find the slope of AH. So A is -3, 3. So the -3 goes at the bottom, 3 goes at the top. H is 1, -3, so it looks like this. So let's go ahead and simplify that. 3 minus -3 is going to be 3 plus 3, which is 6. -3 minus 1 is -4, so it looks like that. And again, we're going to simplify that. We can divide by 2, so 6 divided by 2 is 3. And 4 divided by 2 is 2. And it's going to be negative, okay? Then we just check, are these opposite reciprocals? So remember, opposite, one's positive, one's negative. Yes. Reciprocals, are they flipped? Yes, they are. So these are perpendicular, okay? So this right here is a way for you to tell me that it is a rhombus. Now, looking at this shape, now is it a square? If it's a parallelogram, so it's a dog, it's a rectangle, it's a poodle, and it's a rhombus, it's a Labrador, then that means it classifies all those three are a classification of this shape, which means it's also a square, okay? So if I was asking you this question, I was like, hey, describe, what would be the best description for this one? You would just say it's a square. Now, the reason we do that is we always pick the classification that is the most specific. So what I mean by that is, if you see a dog, you don't usually just say, or maybe you do, but if you say, hey, that's a Labrador, like I mentioned before, you don't have to say that's a Labrador. Oh, by the way, it's a dog. No. Okay, that's implied. So you always go for the more specific thing. So if I say that is a square, what is implied there is that because it's a square, that's also a rectangle, it's also a rhombus, it's also a parallelogram. Okay, so think of that little diagram that I had with the dog, and I'll show it in the next page so you can kind of see what I'm talking about. And not the next page, let's do the page after that. Real quick. Okay. If you're trying to classify a shape, make your way towards the bottom. So if it's a square, don't pick these. Okay. We're going to go for the more specific one. If it's a rectangle, don't say, oh, well, a rectangle is a parallelogram. So technically I'm correct. Yes, but you want to be a little bit more descriptive. Okay, so we would pick rectangle. So if I do all of this work and let's say it's this, you're not going to pick parallelogram, you're going to pick rhombus. Okay, if I do all of this work and it's all four of them, again, you pick the one that's the most descriptive, which is going to be your square. Okay, all right. This right here was in our last notes. I just kind of want to go over, and that way you can have this maybe to look at for your tests. I'm just going to add a couple of things for parallelograms. We had that opposite sides are parallel, and that one pair of opposite sides is both parallel and perpendicular. Okay, so the four methods that we looked at for a parallelogram were this one: opposite sides are congruent, diagonals bisect each other, and opposite sides are parallel, and one pair of opposite sides is both parallel and congruent. Sorry. Okay. Now for that first one, opposite sides are congruent. You're just gonna get the distance of these sides and compare them, and you're just gonna want to see if the opposite sides are congruent. Okay. This one right here, diagonals bisect each other. That's the one where you use the midpoint formula. Yeah, that's the one where you use the midpoint formula. And if they have the same midpoint, and then that means that they are, bisecting each other. Opposite sides are parallel. That's the one where you use your slope formula. And this one right here is a combination of both of those at the top of this one. Whoops. So sorry. I'm so sorry I keep doing that. This bottom one is just a combination of these two, this one and this one, just FYI. Okay. If I had to pick one, like if I was doing my test and I had to pick which of these four, because you have to pick one of the four, I would either do this one or I would do this one. Okay. And I'll show you why. If you start off with this one can also help you find a rectangle. Because once you have those slopes, all I need to check, now I'm just going to check, instead of the opposite sides, you're going to check the consecutive sides, okay? And you're going to check, are they opposite reciprocal, okay? Another way that you can do for a rectangle is by finding its diagonals and seeing if they're congruent, and use that distance formula for that one. For a rhombus, these are the characteristics of it. Really, you just use the top two. So these two right here are the ones you're using. So all four sides are congruent. Guess what? If you did this work right here, you can use that one for this question. Okay, that's why I recommend these two, because this will help you find whether it has four right angles, and this will help you see if the four sides are the same. Okay. So that's what you could have used there. And diagonals are perpendicular. You could have used your slope formula, and then you just see if they are opposite reciprocals. Now, if it's a square, that means it's going to be a rhombus, it's going to be a rectangle, and it's going to be a parallelogram. Okay. So I would copy this down in my notes for my test. If you want to do a couple of examples, you're going to see next class, you're going to have your last quiz for this cycle. Okay, it's getting closer to spring break. It's getting closer to the end of the cycle. So just make sure that you are studying for your quiz. This is your very, very last quiz. If you have any questions for tutorials or anything like that, Miss Haggard's information is on the homepage. Other than that, next class, you are just going to be having your last quiz, and then you're going to be studying for your second to last test for the cycle. Okay. So happy studying.